2024 has been a huge year for science, and we've welcomed leading researchers from a vast range of scientific disciplines here at the Royal Institution. In this special 2024 Wrapped episode, we're taking a look back at all the incredible voices we've heard over the past year here on the RI Science podcast. So, let's go back to the beginning. Back in December 2023, we released an episode with bioinformatics legend Dame Janet Thornton to discuss AlphaFold, the DeepMind program which helps tackle the protein folding problem by predicting the 3D structure of hundreds of millions of proteins using their amino acid sequence.
What AlphaFold does is to predict the three-dimensional structures of proteins. We already had 200,000 structures, so we had quite a lot of structures. But of course, in all the different organisms, there are millions and millions of structures. And what AlphaFold did was to predict rather accurately the structures that are now available, 200 million of them. So we have in the database at the European Bioinformatics Institute, where I work, we have this database with all these structures in that's available for everybody around the world. So all the biochemistry labs where people are interested in one specific protein can now look up the structure of that protein and be fairly confident that it will be correct, even though it's been predicted. It's not an experimental structure.
In October of this year, AlphaFold creators Demis Hassabis and John Jumper won the Nobel Prize in Chemistry, along with David Baker, for their work on protein structure, prediction, and design. Janet saw this potential of AI as the ultimate solution for predicting protein folding, but also expressed her concerns over the future developments of AlphaFold.
I really don't know how easy it's going to be able to predict the ligands, about the small ligands, because, as I said, the predicting protein structures is the ideal AI problem, because you've got 170,000 protein structures, all made up of identical amino acids. So although they're different because of the different amino acids, they're still the same. So you can, every protein has its arginines, it's the different amino acids in there. The ligands are different. They're much more complicated. Even though they're tiny, they're actually not that well behaved as proteins, which is surprising, because they're really, compared with 3,000 atoms in a protein, these small molecules often only have 30 or 40 atoms, and yet they are quite difficult and they're all different. And I'm sure that there will be a way around it. So I don't know whether it's going to be as easy, but of course that has commercial implications as well. Because if you can predict the ligands, you can begin to design drugs, basically.
Concern over the difficulty regarding prediction of protein-ligand interaction expressed by Janet has since been approached. In May of 2024, AlphaFold 3 was released with improved accuracy of protein-ligand interaction, opening the door to huge advances in future drug development. The impact of AlphaFold on the protein folding world has been monumental in the past year, so it's definitely something to keep your eye on in 2025. AI has been a huge topic this year, and you can still catch up on last year's Christmas lectures from Mike Wooldridge exploring the truth about AI. Just head to BBC iPlayer. Not only has AI aided in our biological understanding, but it's also making waves in the healthcare world. We heard from surgeon James Kinross about how far technology has advanced in the operating room.
Well, the operating room is changing very dramatically. I'll tell you a brief story. So when I was a very junior doctor many, many years ago, they used to have music stands in operating rooms. And the purpose of the music stand was that you could place your surgical textbook on the music stand. So when it was late at night and you weren't quite sure what you should be doing, the nurse could change the page for you as you were going through the steps of your surgery. That is real, by the way. That really did happen. It's horrifying, isn't it?
Comforting.
Yeah. So the modern operating room, I'm pleased to say, the music stands have long gone, and increasingly it's digitized. So what that means is that surgeons are using either tools which are connected to the Internet of Things, or they are using tools which are leveraging information from the electronic healthcare record or connected to the NHS spine, or they're using a sophisticated suite of sensing devices to make their surgery safer, right? And increasingly those are put on robots. So robotic surgery is, it was previously a very expensive operative technique that was used in the minority of operations. The costs have come down, they're now more widespread, and we're seeing them kind of used more frequently. And the driver for robotic surgery isn't really the mechanical advantage that it gives you. Of course, it does give you a mechanical advantage and it is useful, but I think the real value in it is that it is a tool that measures your performance very precisely, and you are able to not just measure your performance as the surgeon, but also the team's performance around you, and improve the efficiency, the precision and the safety of the entire operating room environment. So the operating room is really changing, and obviously a very big part of that change is also how we leverage imaging and X-rays and CT and all these sorts of tools and apply them in the operating room in real time, so that you can give the surgeon vision that they wouldn't otherwise have with the naked eye.
Lots of us may be fairly concerned about AI, asking whether it can mirror human behaviour and what its limits are. We heard from neuroscientist and author Charan Ranganath on the differences between AI and our brains and their role in memory.
So you mentioned the potential lack of creativity. How does memory help us be creative?
So memory is incredible in humans because we do things that are very different than typical generative AI systems. So generative AI, they just absorb massive amounts of data and then try to find patterns in it. Humans actually take in very weird kinds of data. Like, we don't even see the entire world in front of us. We just get little snippets of the world by moving our eyes around. And so as a result, we actually put together much more rich kinds of inferences from much less information. So you wander around the world, you meet people. Maybe when you're in uni, you lived in a dormitory with friends who you wouldn't have met if it just didn't happen that you were living in the same place. And these kinds of unique experiences, somebody gives you a book for your birthday and you read it, and it's something completely outside of your normal experience, you can start to build connections between ideas. And if you look at some of the great artists, some of the great musicians, poets, they're actually people who took a diverse range of influences from their lived experiences and just found unusual connections between them. And this is the kind of thing that we can do because of episodic memory. Episodic memory allows us to take these unique moments in our lived experiences and then recombine them and put them together into new things and synthesize them. And this would be something that is not present in at least current AI systems, because they're designed to just take the common elements of whatever they're trained with, as opposed to the distinctive, unique, weird experiences that we have.
Another area we've seen extensive developments in this year is, of course, space travel. We've had talk of sending humans to Mars, but could humans really colonize another planet? Japan-based astrophysicist and science writer Elizabeth Tasker gave us a checklist of what we are looking for in a habitable planet.
So until we can start probing these atmospheres, we don't know what kind of surfaces we're talking about. Now, that has been the case, and it still is mainly the case now, but we are pushing towards going from this detection era, where we find out if the planets exist, through to a characterization era, where we try to say, we know this planet exists, now we want to know more about it. And of course, that is tied with the idea of whether these planets might be habitable. Knowing if they're there is not sufficient. And that's even true if we know the orbit. So in this detection era, when we wanted to talk about habitability of planets, the only thing we could really do is look for planets that were about Earth-sized, because in which case they probably are rocky as opposed to gaseous, so more like Earth than Jupiter. And so they've got a surface. And then we would say, well, if they receive roughly the same amount of starlight as the Earth receives sunlight, we're going to say they are more Earth-like. In particular, in that instance, we can say they're in the so-called habitable zone. But the habitable zone is, it's linked with the amount of starlight that planet is receiving, and whether that's good for a nice, temperate, holiday-worthy surface will depend on the planet itself. So again, to do a rather stark example to drive this point home, the Earth is, you'll be pleased to hear, in the habitable zone around the Sun. But so is the Moon, and so is Mars, and neither of them have comfortable surfaces. Now, the reason is that they are small bodies and they have very thin atmospheres. So therefore, they would need a lot more starlight or sunlight to have a warm surface. So when we talk about the habitable zone, especially when we apply it to exoplanets, we usually mean the place where the Earth could support liquid water on the surface. And by Earth, we mean a planet with our atmosphere and our surface temperatures and pressures. That means that if we found another Earth, if there was another Earth out there, it would be in the habitable zone. Therefore, the habitable zone is useful as a search location. However, it is not true that every planet found in the habitable zone will be an Earth. It could be anything. So that's where we were and where we still mainly but not completely are at the moment. What we're edging towards with this era of characterization is to try and detect something about the planet's atmosphere. And that will give us more of a clue to whether we're talking about, say, an Earth or a Venus or even a mini Neptune, which also doesn't sound particularly holiday-worthy.
This year, we also had a little look back at the past, answering some age-old questions, like what came first, the chicken or the egg? Jules Howard, a zoologist and science writer, joined us on the podcast and gave us his take.
Does that mean we finally have an answer to what came first? Is it the chicken or the egg?
Do you guess how often I'm being asked that question? Do you know what? At first, as I was writing this, I was like, I bet people are going to ask me that question. That's going to be a popular one. You often find there's one thing that people come back to, which is really good, really important to have a starting point. And the chicken and the egg, that paradox, we love it. As you know, human societies, it's a classic. So at first I was like, any zoologist is going to go, right, listen, chicken, 10,000 years old, that is relatively recent domestication. And then you're like, well, you know, chickens are part of the group, obviously, of birds. Birds evolved 150 million years ago from theropod dinosaurs, the two-legged dinosaurs. So, yeah, we're talking 150 million years. So 10,000 for chicken versus 150 million years for birds. I've got to say it's got to be the egg that came first. However, I must admit, in the last couple of weeks, the more I think about it, I've actually turned into one of those kind of annoying, like, oh, yes, but it's a paradox. You think about, you know, jungle fowl running around 10,000 years ago. There must have been a moment when male jungle fowl met female. Their genes go into that egg, and inside that egg is the exact genetics of the organism that will become chicken, or it will be named chicken. It is a really, really beautiful question. So I found myself, and also, like, what is a species really? Like, what is a chicken really?
Well, that's the thing. Is it what came first, the chicken DNA
yes.
or the egg DNA?
Yes.
And then you just go down that whole rabbit hole. So
yeah, exactly.
Maybe we'll never know.
Maybe we will never know. But I tell you what,
Speaking of evolution, the role of women in its early stages has long been overlooked. Kat Bohannon visited the RI back in April of this year and argued that our greatest invention, the single most important factor in our success as a human species, came from womenkind.
Nearly every human culture, historical and present, has a number of local traditions that effectively work to reduce maternal bleeding, to coordinate the timing of the pushes to go with the contractions, to reduce the risk of infection, even if they don't particularly have a knowledge base around that's what they're doing. You don't gotta know that copper instruments can potentially be bactericidal, but hey, there's fewer people dead, right? You have many traditions that effectively work to keep more female people alive through our crappy reproductive system, which is why I make the claim in the book that our most important invention was not fire or sewing, I did like sewing, or writing, certainly that's recent, or even stone tools exactly. It was gynecology. It's why we're not extinct, more than likely. It's why our species, I would think, in this frame, even came to be, because it came on board before we did.
Kat also told us about the lack of female representation in clinical studies, revealing the truth behind why the rates of car crashes are higher for females.
We also have commonly prescribed sleep aids to people of all genders, both sexes, right? And there was one very popular one, commonly known as Ambien. We found out, and the FDA finally changed its guidance, that Ambien should be given to females at about half the dose of the male. So not your 10 milligram, but your 5, okay? And we found this out primarily because of clinical data coming in about side effects lasting longer, but also because of car crashes. When do you take a sleep aid, people? You take it the night before you do a thing. Turns out one of the things you do might be driving to work. Okay, so the car crash data was filtering in, and eventually they put the picture together. Oh, females who had taken Ambien the night before were more likely to be in a car crash the next morning than males who had taken or people who hadn't taken at all. And the point at which the FDA finally changed the dosing recommendation, well, it had been on the market for 21 years. I think we can do better.
Representation isn't just missing in clinical studies, it's missing in the people conducting the research too. Physicist Jess is using Wikipedia as a tool to tackle the lack of representation in science and academia.
Onto Wikipedia. And she taught me about how to edit Wikipedia, how simple it was editing Wikipedia. It's basically like any application that everyone's familiar with, like any Microsoft application. You just press edit rather than read on a Wikipedia page. But also about these huge kind of gaps in Wikipedia's knowledge. When you look on it, and when you're researching for a story or doing your homework or whatever, it feels very complete, but actually there's huge gaps. Anything to do with the global south, women's health, anything about topics or issues that aren't immediately interesting to the 90% of Wikipedia editors who are white men from North America.
Yeah.
They're underrepresented on Wikipedia. And when I started editing, of all of the biographies on English language Wikipedia, about 17% were about women. So you've got this absolutely gigantic encyclopedia that is used by everyone in society, journalists, lawyers, medics, professors, children, their parents, their teachers, you name it. And yet it's factually incorrect in that it's saying only 17% of the people who are notable in the world are women. And that's not just women scientists, that's women casting directors, women musicians, women philosophers, women theologists, whatever. And obviously that just frustrated me so much. And like you said, when I get angry, I have to do something. So then I just started writing their Wikipedia pages.
Women in sport was a big topic this year, with the Paris Olympic and Paralympic Games in August, and with US Sevens rugby player Ilona Mayer tackling gender norms in sports. However, research into sex differences when studying the brains of athletes is scarce. Exercise neuroscientist Flaminia Ronka told us more about the impact of head injuries on male versus female brains.
In general, across the board, and this is very important, in both males and females, hitting your head against things is not a great thing. And there are sports that don't really exhibit lots of a high prevalence of concussions, but you do get a higher incidence of head impacts, even though they're not concussive. So take football, for example. You're heading the ball and you're putting your brain under quite a substantial G-force when you do that. So then you've got boxing. You don't necessarily need to be knocked out, but if you're getting hit repeatedly in the head, it's not great. And there is research that's starting to look into this. And in both males and females, it has a detrimental effect. And this detrimental effect only seems to start to show up later in life in our 50s and 60s. So I think on one end, there's less research in females because there are probably less female retired athletes from certain sports. Because unfortunately, there was less investment in female sports, say 30 years ago. So fortunately, that's improving. I think what's worrying in females is that women do tend to be at greater risk of developing Alzheimer's and dementia later in life, particularly after menopause. So in people who do suffer from more severe symptoms in menopause, that tends to be related to changes in brain metabolism, which then kickstarts the whole process of generating the amyloid plaques, which then generates dementia and Alzheimer's, say, 7 to 10 years after that. So unfortunately, we are at greater risk.
Laminia also gave us a look inside our brains and what goes on when we exercise.
So much that goes on in our brains and we still need to understand. So at a physiological level, there are hormones changing, there are neurotransmitter levels changing, but also from a cognitive level, there are different cognitive processes that we engage in. So hormones that have been identified recently and are a big focus in the field are BDNF, the brain-derived neurotrophic factor. This is a hormone that supports neurogenesis, so the formation of new neurons, but also synaptogenesis, so the formation of new synapses. So it helps our brain function in the short term, so immediately after a bout of exercise, but it also, more importantly, supports our brain health in the longer term and in creating new neurons and new connections in our brain, which is why we start to see relationships between the onset of Alzheimer's and cognitive decline and fitness later in life, for example.
For this year's Christmas lectures, supported by CGI, Chris Van Tullicum will take us on a journey to discover the truth about food. This year brought us a range of food content on the podcast, including cheese expert Bronwyn Percival, who told us how food processing is not a new concept and has been performed for thousands of years.
And there's some very interesting anthropologists out there who are looking at, archaeological sites where they find pot shards which have holes in them and which they have done, analysis of the residues on those pot shards and see that actually they were making cheese, thousands and thousands of years ago, probably about the same time as they were domesticating these animals to get the milk from them in the first place. And in a way it makes perfect sense because you have animals that by and large give milk during the summer, and that, this milk has incredible nutritional value, but you've got a lot of it when you've got it, and then you've got months and months without it when the animals dry off. And that actually cheese making is this tremendous technology for taking the excess moisture out of this milk, so shrinking it by a factor of 10, getting rid of the lactose by the fermentation of the milk so that you make it more digestible, and preserving it so that you can eat it in the wintertime as well. So it's this brilliant technology, and it's in a way not surprising that there was intense evolutionary pressure for people to figure that out as quickly as possible when they were starting to deal with fluid milk as a food source.
Bronwyn also told us how cheese could be unlocking the future of research on our gut microbiomes.
I'm interested in cheese science for exactly the reason that you state, because better cheese is better for the industry, and I'm excited by the prospect of better cheese. But actually, there's some with the rise of really high throughput DNA sequencing and metagenomics, actually there are a number of scientists who are approaching artisan cheese as a really interesting model that they can use to study microbial interactions and community formation. So I actually was lucky enough to spend 2 months in the lab of Rachel Dutton and Ben Wolfe at Harvard back in 2014, and the point of their research was not necessarily to study artisan cheese. In fact, they weren't really that interested in the artisan cheeses at all, but Rachel had this brilliant idea that looking at cheese rinds was interesting because, unlike the gut microbiome, this is a bacterial or a microbial community that's easy to study in the lab. You don't have to have anaerobic conditions. It grows at fairly comfortable temperatures, and you can make tiny little experimental cheeses and grow things and actually start to look at how these intensely complex communities of microbes are growing together, are forming, are communicating with one another, and start to use the phenomena that we're finding happening on the outside of these cheese rinds to inform our understanding of how microbial communities form, which I'm sure, as you know, with all of the interest right now in things like the gut microbiome and health, is really pertinent within the scientific community in general. And the most important thing about that at all, and for me the most beneficial, is we as a cheese industry got a huge amount of information from their study of sort of 130 artisan cheeses and their rinds, where they were able to do very kind of in-depth sequencing of the communities of molds and bacteria growing on the outside of these cheeses. It was revolutionary for us as an industry to start to understand what's there. But actually for them, looking at these cheeses as opposed to the sort of much simpler cheeses that you would find in the supermarket, say, where you're working with milk that's been pasteurized and with, a kind of note-by-note approach to making a cheese with only known quantities in terms of microbial strains. They're very simple systems, whereas actually using these artisan cheeses gave you much, much more complexity, but actually scientifically a much more interesting thing to study. So yes, I think cheeses have played an important role in starting to help us understand those community interactions, even at a very simplified level.
We also heard from Mike Shaver, a researcher in polymer science and sustainable materials, who told us why food is packaged the way it is, and the effect of this packaging on the environment.
I think the first thing to think about is what the alternatives were, right? And so you used to go to a shop and you used to buy something which might not have any packaging at all. So we think about some of the items we would have bought from a grocery shop. But actually, the real benefit of introducing plastics in packaging were really twofold. So the first is that they could increase the shelf life of materials, and that would prevent food from spoiling. And actually, the carbon footprint of food is actually higher than the package itself in many instances, in most instances, really. And so we were able to both prevent food from spoiling and get a really secure and more efficient supply chain for that food while keeping our carbon footprint low. And the second thing is actually spoilage. The consequence of that food going off is that food is a lot safer than it used to be. So, we have fewer people who are going to get sick from food. We now see that food recalls are very rare, and that's because the plastic can offer a lot of protection for those materials. And because that offers protection while being a really efficient material to make and a very lightweight material, so an efficient material to transport, makes it very sustainable. And when you then look at the difference between purpose and what some of the marketing is on new packaging, it becomes a real challenge to unpick as a consumer.
To draw a close on this year, let's take a look at what 2025 will bring us, including the year of quantum, marking a century since Schrödinger developed wave mechanics, amongst other noticeable discoveries in quantum physics. As a researcher in this field, Jess Wade gave us a rundown on the research we are celebrating 100 years later.
Things going on in chemistry. And then in the early 1900s, Planck and Einstein actually started determining or defining what would underpin quantum science for the next 100 years, which was saying actually these energy levels are quantized. So they're very specific energy levels that electrons can take within an atom. Photons can have very specific energy levels. And that quantization is where we got quanta, the kind of step understanding of that. Schrödinger then came along, and de Broglie, that we learn about at school, came along and said, actually, we've got to rethink this entirely. Photons don't only exist as a wave, and electrons don't only exist as a particle. There's this kind of duality between them. Electron can be both a particle and a wave. A photon can be both a particle and a wave. And actually, the fact that an electron also has a wave function associated with it is how we design fancy electron microscopes. So it completely underpins technologies we really, really rely on. Schrödinger then came along and formulated this expression, this Schrödinger equation, this relationship, this wave function, that really described the wave function of matter, the wave function of particles, of electrons, of photons, where you have this kind of distribution, this wave function, that describes their probability of being somewhere. And where you've got a very, very high amplitude of your wave function, that's where your electrons or your photons are most likely to be. So it was a step change in the way that we thought about describing matter and understanding it.
2025 marks the 200th anniversary of the Christmas lectures and discourses here at the RI, as well as the isolation of benzene. Around 100 years later, the cyclic nature of benzene was confirmed by crystallographer Kathleen Lonsdale, who worked at the Royal Institution during her career. Jess Wade told us more.
Researcher called Kathleen Lonsdale.
It was
an Irish crystallographer who was the one who kind of defined the structure of benzene and gave that information to the world. I kind of like these stories in science where you had chemists arguing for like 100 years about precisely how the carbon atoms were sitting in benzene and how they were connected to one another. And then it took Kathleen Lonsdale and her ability to fire X-rays at something and use your isolated benzene that we got from a few floors below here to be able to define that structure that we could go on to make lots of different types of molecules since then. She was also one of those kind of fantastic people that you read about in science where they not only cared passionately about their science, but also so much about society as well. She was a huge campaigner for prison reform. And I just think, to see that kind of insight, and, if you think about all the scientists that have inspired you, they're humans alongside the research they do.
What a fantastic year of conversation we have had on the podcast, and 2025 promises us even more. If there are any particular topics you'd like to hear on the podcast next year, let us know by leaving a comment. Thank you for tuning into the podcast, and we'll see you next year.